In this animation, we will examine one way to create an electromagnetic wave. To create this electromagnetic wave, we have an antenna consisting of a conductor connected to an alternating voltage source. We will look at the electric field at point P when the alternating voltage source is turned on. With the voltage source turned off, no charge flows in the antenna, and as a result, no electric field exists at point P from the antenna. When the voltage source is turned on, positive charge starts to accumulate at the top of the antenna, while negative charge simultaneously accumulates at the bottom of the antenna. At point P, the electric field will point downward, and it will grow in strength as the charge accumulation builds up. We see this by the dashed red line in the animation. This red line is tracing out the magnitude of the electric field as the voltage source changes the charge distribution on the antenna. At 1/4 of the varying voltage source's cycle, the electric field will be at a maximum at point P. After this instant, the voltage source will cause the number of positive and negative charges to gradually decrease. As this happens, the strength of the electric field at point P also decreases in time. Halfway through the varying voltage source's cycle, we arrive at a situation similar to our starting time. There are no positive or negative charges on the antenna, and, therefore, no electric field is produced at the point P at this instant in time. After this instant, the charges continue to switch locations. Negative charges start to gather at the top of the antenna, while the positive charges simultaneously gather at the bottom of the antenna. This will change the direction of the electric field at point P. Notice that the electric field is now pointing upward instead of downward. As more and more charge accumulates at both ends of the antenna, the strength of the electric field increases. At 3/4 of the varying voltage source's cycle, the magnitude of the electric field is again at its maximum strength, but in the opposite direction. After this instant, the voltage source will cause the charges to gradually decrease. As this happens, the strength of the electric field at point P decreases. After one complete cycle, we arrive at a situation similar to the time at which we applied the alternating voltage and halfway through its cycle. This process will repeat itself as long as the alternating voltage source is operating, and this is one way to create an electromagnetic field.